I'm now going to be doing page 439. Number 29. Suppose a large candy machine has 45% orange candies. Imagine taking an SRS of 25 candies from the machine and observing the sample proportion p hat of orange candies. Part A states, what is the mean of the sampling distribution of p hat? Why? Well, we know that the mean of our p hat, of our sampling distribution p hat, is equal to p, the population proportion. The population proportion is 0.45. So on your normal curve, down the center, you would put p is equal to 0.45. Part B says find the standard deviation of the sampling distribution of p hat and check to see if the 10% condition is met. So for part B, we need to find this part on our curve. The standard deviation is equal to the square root of p times 1 minus p divided by n. Please remember that this p in here is your parameter, not your statistic p hat. That's a very common mistake. So we write in there the square root of 0.45 times 1 minus 0.45 divided by n, and n is equal to 25. When we evaluate this, we get our standard deviation equal to 0.0995. They ask you to check your 10% condition. Your 10% condition is the independence condition. When we check that, we need to make sure that 10 times our sample size is less than or equal to our total population size. Checking that, we have 10 times 25 less than or equal to capital letter N. So we say 250 is less than or equal to capital N. We are not given a capital N here. Okay, oops, should remove that. Sorry, let me erase that. Okay, whatever, I can't erase that. 250 is less than or equal to capital N. Since we're not given that capital letter N, we have to take an assumption here. We have to assume that 250 is less than or equal to all candies in a large machine. All right, so we've answered part B. We have our standard deviation and we have our 10% condition. Next, we say, is the sampling distribution of p hat approximately normal? This is our normal condition. Oops. This is where we have to check n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. So we check 25 times 0.45 is greater than or equal to 10. And then we check 25 times 1 minus 0.45. Is that greater than or equal to 10? They both hold. The first one is 11.25, which is greater than or equal to 10, and the second one is 13.75, which is greater than or equal to 10. This condition now allows us to use that normal model. Part D now says, if the sampling size were 50 rather than 25, how would this change the sampling distribution of p hats? Well, our center would not change. That's going to stay the same. P is equal to 0.45. But our standard deviations are going to change. Why? Our standard deviations are based off of the sample size as well as the parameter. If this n is now 50 instead of 25, we can actually compute it. When we find that, the standard deviation of 0.45 times 1 minus 0.45 divided by 50, your new standard deviation is equal to 0.0706. This makes sense. Like we showed in the law of large numbers, the more repetitions, the higher your sample size is, the less variability. Your variability is your standard deviation. That's spread, how much things change. That was page 439, number 29.